Good morning. Thank you all for being here. I'm Nikki Springer. I'm the director of the Renewable Thermal Alliance, and we're quite excited this morning to share with you a special project that we have been supporting for over a year now and look forward to continue supporting in the future. This project came out of our 2018 Innovation Grant funding cycle, and so we've been supporting this for the past year, and we have just awarded them an additional year of funding to continue to support that. The project is run by the Clean Energy States Alliance, and we have 3 of the project leaders on with us today, and they're going to share with you a tool that they are developing and expanding to help calculate clean heating and cooling options. So with that, I know we have a full hour today. I'm going to turn it over to Val. We will hold our questions to the end. We have 3 speakers today, so if you want to enter some questions into the chat function, which you would see if you hover at the bottom of your Zoom screen, it looks like a little conversation bubble. Enter those questions in there, but we won't actually address the questions until the end of the webinar. Otherwise, let's get started. Val, you want to take it over?
Here I am. Hi, everyone. I'm Val Story. Thanks for joining us. We are super excited to have so many of you listening in today and participating on the call. I know you must all have your hands full managing, working from home, and juggling various responsibilities. So thanks again for taking the time. As Nikki said, we do have a packed hour for you. So before we dig in, I want to give you a quick overview of what we're going to be covering today. First off, I'm going to be introducing you to the project, giving you an overview about its partners, what we're trying to do, and then sharing with you a couple of screenshots of what is right now a prototype tool. And we'll be going over the inputs and outputs of the tool. And then I'm going to switch over to Damon Lane from VEIC. He'll introduce himself, and he's doing the modeling, and he's the lead analyst on the tool, and he's much more intimately familiar with the guts of the tool than I am, or that Matt is, so he's going to be covering that. And then lastly, Matt Miller from NYSERDA, he'll introduce himself when he starts his presentation. He's going to run you through a few more scenarios that he's run and plugged into the tool. Okay, next slide, please. All right, so with that quick intro, let's get started. As I said, I'm Val Story, and I work at a nonprofit organization called CESA as a project director. I'm mostly focused on building electrification, clean heating and cooling, and some offshore wind policy. But as an organization, which is based in Montpelier, Vermont, we work with a membership of state energy offices, federal energy offices, and related energy agencies across the US to advance renewable policy. And we do this through information sharing, regional projects like this one, and through technical assistance. And then on the next slide, you can see all our members. And we'll just breeze through that. So that gives you an idea of CESA's membership base. So let's dive into the meat of this project. Next slide, please. So for this project, we're working with some of our members in the Northeast, plus Avangrid, which is a sustainable energy company that, among other things, owns electric and natural gas utilities. But our other project partners are Connecticut Deep, the Connecticut Green Bank, Mass EC, and NYSERDA. And we've also partnered with UMass Clean Energy Extension. They've been serving in an advisory role, and we've been consulting with them throughout the project, looking for their expertise, advice on various aspects of the tool. And then, as you heard, VEIC is our project contractor, and they've built the tool as you'll see it, based on a scope of work that the group developed, and we've had lots of back and forth, of course, with VEIC and with feedback from the group. They've developed the prototype tool that we'll be sharing with you in parts today. As Nikki mentioned, this work would not have been possible without the support of our funders. So RTA supported us about a year ago, and they've given us another grant for this upcoming year. And we also have funding support from the Hunt Foundation, plus each of the members that I just mentioned has contributed financially to the tool. So thank you to all of you. So why are we building this tool? As you are all aware, each state that's involved in this project has been working independently to build and support a renewable heating and cooling market through whether it be renewable heating and cooling goals, or through incentive programs, or through residential programs like Heat Smart. And in our effort to support market development, we thought that a regional tool that homeowners themselves could use would help support market development. And so we are developing a tool for a homeowner to use. It's a residential tool that gives an estimate of cost savings and greenhouse gas savings for switching to a renewable heating and cooling technology. We wanted a regional tool. We wanted a tool that could have uses consistent methodology throughout the region. So while the outputs of the tools are going to vary, whether you're based in Connecticut or Mass or New York, the background assumptions and the methodology that the tool uses are going to be the same throughout the region. And then lastly, what are we building? As you just heard, we're building a simple tool that a homeowner can use to easily calculate the cost and emission savings from investing in a clean heating and cooling technology. When this project is finished, the tool is going to be published online. So it's going to be a free online tool that is, again, can't stress this enough, that is super easy to use. So we've been very mindful in choosing the number and the type of input fields. We want to have enough input fields so that the homeowner can give us a good sense of the type of home and the current heating system he has. But we want enough input fields so that we can get an output that we believe is pretty accurate. So we've been trying to strike a balance to not have too many fields so that the homeowner doesn't walk away, but enough to have high confidence in the tool's outputs. Next slide. All right, so before we move on to the field, onto the input field, I wanted to start off with this slide. We are making the assumption that some of the homeowners that are going to be using the tool don't know too much about clean heating and cooling technologies. And because this tool asks you right off the bat to choose one clean heating and cooling technology, we have created a clean heating and cooling matrix. And so on this matrix, a homeowner can answer some pretty easy questions about what he may or may not want so that they can choose a technology that makes the most sense with the home's current configuration and the homeowner's desires. For example, if you know you want a C, by this chart, you wouldn't choose a pellet boiler from the drop-down menu. Okay, next slide, please. All right, so what I've done for the next few slides is I've taken screenshots of the prototype tool. Again, the tool is currently under development, and while we're getting close to a final Excel-based product that then goes to a web designer who then is going to turn this really robust spreadsheet into an easy-to-use online calculator, we're not there yet, and so we didn't want to share the guts of this tool. So what you're seeing are screenshots for the next few slides. So, well, let me say one more thing before I dive in. Let me tell you a little bit about what the tool does not do, because we're going to spend the majority of the hour talking about what it does do. So the tool, in the end, it doesn't compare one clean heating and cooling technology against another. The user is going to choose just one tool, and then one technology, and then that technology is going to be compared against the homeowner's existing system. The tool also doesn't assume any heating distribution changes. It doesn't cover new home construction, it doesn't cover multifamily buildings, and it doesn't account for the cooling gains from installing some kind of heat pump. So the cost savings from installing ground source heat pump are not compared in the end against you going out and purchasing a new cooling system. All right, so now that we've covered what the tool doesn't do, let's move on to what it does. Okay. This tool, oh, sorry, go back one. Thank you. All right, so the first input field, you'll see column C, row 3, zip code. So this tool is zip code based. The zip code is the basis for assigning incentives, energy fuel prices, emissions factors, and weather-related data. And then the weather-related data is then used to calculate capacity and energy consumption. Damon can explain this further in more depth in a few slides. So after you've entered your zip code, there's a drop-down menu at the red arrow, and this is where there are 5 different clean heating and cooling technologies: pellet boilers, ground source heat pumps, air source heat pumps, both ducted and ductless, and you can also choose heat pump water heating and solar hot water. From there, the user chooses whether or not he or she would like domestic hot water. And for example, if the user has chosen above that he's interested in a pellet boiler or a ground source heat pump, this field would be auto-populated with yes. And then the tool is going to add about 15% to the overall system size. We then move on to conditioned area. This is another input field. All the yellow are user input fields. And in this field, you can enter between 1,000 to 2,500 square feet, which is important because later in the tool, if a user doesn't enter any fuel consumption data, then the tool is going to calculate the home's energy load based on the conditioned area data that the homeowner has entered here. Then line 13, column C, before 1950 is what's shown on the screen. That's another drop-down menu, and you can choose by decade beginning. 1950 to 1959 is the first decade, and then it goes all the way to 2000, and then 2000 to present is lumped together. Next one, the next two, actually, I'll cover these together. Home efficiency and behavioral efficiency are subjective or qualitative fields that feeds into the adjusted heating intensity and then the water heating use. And so you can choose from below average, average, or above average, and this is assigned a numerical value for the tool's calculations. But these two are fields that the group really felt could give us a more detailed and more nuanced view of how energy is being used in a home. So that's why those two are included. Next slide. Thank you. All right, sorry, I'm breezing through all this quite fast. All right, so slide 7, this is the next slide. So up at the top, line 26 is another user input field. It's a drop-down menu, and you can choose from any of these existing heating distribution systems. But for example, if on the last slide that I showed, if you had chosen that you're interested in installing a ground source heat pump, and if here you indicate that your distribution system is anything other than a radiant system, the tool is going to pop up, not an error message per se, but an error message that warns you that the clean heating and cooling technology you've chosen and your current distribution system might be incompatible. All right, so after that, we move down to existing heating fuel. It's circled in red, and you can choose up to 3 different types of heating fuel. So let's say you mainly heat with propane, but you've got a wood stove in the house and one of your addition rooms is heated with electricity. So you can choose up to 3. You can choose the percentage or amount of fuel you use, and you could do that through a variety of units. All the way over on column E, over allowed value, the box in green, you can write in whether the amount you've entered in column D is by gallons, dollars, quarts, etc. Okay, then in the next section is which covers the new clean heating and cooling solution. This is really where we ask the user what share of the heating load they'd like that technology to cover. It's really getting to how are they going to use the new system. So earlier above the clean heating and cooling solution, you indicated auto-populates on the first row. So here, row 48, column C, is already filled with pellet boiler, because this is assuming that on the first page you indicated that you were interested in a pellet boiler. And then column D, the green, is auto-populated but allows for a user override. So for example, here the tool generally assumes that if you're installing a pellet boiler, that's going to cover 100% of your heating load. But here I've changed it to 80% and assume that maybe there's a room that maybe you want to keep your backup furnace, or maybe there's another room that's on a different system and 20% of the heat load's going to be carried by that. Okay, next slide. Okay, this is the last page of user inputs. And again, I know this is pretty overwhelming. This is on a spreadsheet, so the real version, the online version will not look like this, but this on this last page, this section covers domestic hot water and cooling needs. So existing hot water, again, is a drop-down menu at the red arrow, and you can choose how your current hot water is currently heated. Then the next yellow field asks how many people live in the home. And then this data is used to assume efficiencies and energy consumption. And then lastly, the last yellow cell with the red arrow is the existing cooling system. It's another drop-down menu. You can choose none, room, or central AC. And then the share of cooling is auto-populated. So for example, if you've chosen a ground source heat pump, this is down the green area over on column D. If you've chosen a ground source heat pump, the tool assumes that 100% of the cooling is going to be covered by that new system. But again, these values can be overridden. So just breeze through all the inputs. You can go to the next slide, please. I'm going to come back and run you through some of the outputs, but first I wanted to switch it over to Damon, who's going to really talk to you about the methodology, the assumptions, and the calculations that have gone into this tool. So I'll be back. Thanks.
Thanks, Val. That was a good introduction. And now I'm going to try to go through a bit of the assumptions and method that the tool uses without getting too in the weeds or spending too much time. I think Val did tee it up nicely, so some of these concepts have already been introduced, but I'll add where we're getting some of the assumptions and data sources. Next slide, please. So this is an overview of how we're calculating the energy consumption or estimating the energy consumption for cooling, heating, and water heating. I just listed them in the order they are on the slide, but heating is really the focus of this tool. And Val showed how the user can enter heating by fuel units or their kind of bill costs directly. But this flow is more showing how we would use their conditioned square foot and an assumed kilowatt hours per square foot or kilobtu per square foot of heating if the user doesn't input heating energy. And actually, even if they do input heating energy, we're going to run this analysis anyway. And if there's a big difference between what we come up with from this and what they entered for their fuel, we can flag that. And we haven't really determined what exactly that would look like, but we might advise the user they may have made an error entering their fuel and using different units or a decimal error or something like that. Where we're getting this information for the kilowatt hours per square foot or kilobtu per square foot is from the Residential Energy Consumption Survey that EIA does. The 2015 version is the most recent we have, and they offer microdata that allows you to create custom tables. So these numbers are coming from custom tables that are filtered for the Northeast and are organized by heating or cooling degree bins and home vintage. So we're using the age of the home that people have given them and the climate as indicated by their zip code to figure out which data to pull for them. But for each combination of heating or cooling degree bin and home vintage, we're pulling from the REX data the 25th percentile of the median and the 75th percentile and using the user's efficiency range or efficiency rating input to determine where they fall in that range. If they say they're average on both, they're getting the median, but they can move up or down within between the 25th and 75th percentiles depending on what they said. The water heating is a little bit more straightforward because it's driven by people and not by the square footage that may or may not be the entire home and not by the percentage of heating that people are going to use, but it also does use a a custom Rex table that uses the same different quartile ranges based on the efficiency that someone has input. Next slide, please. So once we have the energy, we'll be using the energy for emissions and operating savings in a moment, but we also want to try to figure out what the system size would be, or the capacity. This is really quite tricky because we're not asking, we don't really have enough information to do a manual J calculation or a manual S, but we want to provide at least a ballpark here because we think some of the users aren't going to really have a concept for how much these different systems cost. And we need to know the capacity to know how much they'll cost. So we're using what we have and assumptions to try to at least come up with an estimate of that. So you can see some of the inputs here. We're using it based on some of the energy we've already calculated and based on some weather data, including design temperatures, as well as whether people have selected whether water heating will be part of their system or not, and whether they would remove the old system or whether the new system will be in addition to it. Next slide, please. So this shows we have two different paths. For ductless air source heat pumps, we're using the winter design temperature and the efficiency score to determine a capacity per square foot. For central systems, we're using the energy estimate and monthly and hourly factors that have just been used conventionally for this type of analysis. And that will give us a capacity of those types of systems. So both of these would give us a capacity number that we can use for the capital cost that the system would require. Next slide, please. On this slide, we see the cooling, heating, or water heating energy that we calculated previously coming in, and combining that with the system types as well as efficiencies. We can use these pre and post efficiencies to determine the fuel savings. The new system efficiencies are from, some of them are from Massachusetts evaluations where we have those. And that's important because the weather and how heat pumps, for example, are used can really vary on their COP and capacity and how well they can really deliver. And they're going to vary throughout the region. We didn't yet have enough, I don't think there's enough data kind of out there to really vary this by, say, heating degree day bin, but we at least do have a Northeast regional number, and Massachusetts does sit in a kind of moderate New England or average New England area that can provide a decent starting point for this number. A lot of the existing system efficiencies are from the EIA Annual Energy Outlook, and it's not a projected number, but it is their 2017 residential efficiency, so that we're trying to provide consistent assumptions that can apply. And since this tool is doing heating, cooling, and water heating in a lot of different kind of paths and combinations with different replacements, we were trying to lean on data sources that can provide kind of full tables with all these different possibilities, rather than it's possible there's some kind of offhand or one-off assumptions that are better. And we have in a few cases replaced data with those, but a lot of the sources we are trying to use larger ones that can provide a lot of the inputs. This slide also shows at the bottom that the zip code is used to calculate the dollar savings for energy. And that's using, of course, the energy savings with the fuel prices. And the fuel prices are from EIA for fossil fuels and electricity. And all of these have APIs, which would allow the website to fetch new prices automatically. But we've talked about probably not wanting to do that too frequently. We don't want a user to return to the tool and feel like they're running the same scenario but get different results. But we do think some kind of auto scheduled update that pulls only the heating season prices would be a useful way to use that API. The wood prices come from either the Biomass Energy Resource Center, which is a program of VEIC where I work, and from the New Hampshire Office of Strategic Initiatives, because there's not, wood heating is a more regional thing than EIA would care to have data on. Similarly, there's a very parallel path where we use the energy to calculate emission savings, and we're using those factors by zip code from EPA and EPA eGrid, except for Connecticut and Massachusetts, which have a study that they're using for their electricity emissions factors. Next slide, please. After all of what we've covered so far, it's relatively simple math to come up with a net capital cost after incentives, and I didn't show, but Val did talk about how we'll use the zip code to calculate incentives that are available. And we have calculated the savings in fuel and the change in what types and amounts of fuel people are buying. We can use that to come up with a first year change in energy spending and a simple payback. We're not forecasting energy prices for long-term results, and that's a tricky thing that some tools do, but of course a lot of tools get accused of being too optimistic in that. But simple payback is this widely understood metric that's not perfect, but it does give some sense. And it is an implication, or it's implying that energy prices and weather are staying the same, which of course is not true. And so it has its weaknesses, but we did want to have simple outputs to go with our simple inputs and make this a easily understandable, kind of quick to run tool, even if we are trying to do a lot of assumptions in the background and handle different situations. So I think that's all I have for this section, but definitely going to hang around for any questions anyone has.
Great, thanks, Damon. Yeah, I just wanted to touch on a few things to give our audience a sense of, where we started, where we've been. I think this is the third or fourth iteration of the spreadsheet that we've seen, and we've certainly had to make adjustments. Like Damon said, we've gotten incentive values from various incentive programs in the 3 states we're working with, but again, some of those data sets aren't that robust, so we've had to look, as Damon mentioned, to different places. We've fiddled with the capital costs data as well, and we're just working really hard to make sure this is a robust tool with outputs that we feel confident in. So that said, what's up on your slide now is a sample output. Both Matt Miller, who's going to run you through a few other scenarios, and we've run several scenarios, and we've done some screenshots or created new tables to give you a sense of some sample results. And I think overall, from the various scenarios we've run, we're getting pretty variable results. And in terms of payback, especially with natural gas, and this isn't that surprising, but what we're finding is that the payback results are discouraging. Again, not a big surprise, but it would discourage anyone on natural gas to switch to renewable heating and cooling, which brings up another point I wanted to make sure I mention, is that in the end, and we haven't developed the output yet, but the homeowner isn't just going to get data, for example, like what you see on your screen, but ideally is also going to get a Word or PDF document that explains the results and puts it in context, talks about what is and isn't covered by the tool. So what we are finding is that payback is best with some combination of electric resistance heating and then another high cost fuel like fuel oil. The tool, despite some of these high payback scenarios that we are seeing, the tool is working correctly. Especially what we're seeing is on the emissions saving side. The emission savings are significant. For the scenarios I've run, it's very clear that you get the most efficient emission savings from switching to a ground source heat pump. Let's see. So let's run through this sample output. So again, as I mentioned earlier, it's a zip code based tool. So I choose zip code 02121, which is Boston, Massachusetts. I indicated that I was interested in a ductless air source heat pump and that I was not interested in domestic hot water, assuming I was going to keep the current system that I have and the ductless was going to be supplemental heat. I indicated that I currently use 100% fuel oil through a furnace with hot air ducts and or registers. I don't have any secondary heating systems. Let's see, my existing domestic hot water is fueled, is run on fuel oil. I don't have existing cooling. My condition area is 1,500 square feet. My vintage of my home is from the 80s, and I have average home energy efficiency and behavioral efficiency. And I'm looking for the heat pumps to cover about 60% of the load. And then you'll see on the right-hand side of your screen, the outputs are broken up into low estimate and high estimate outputs, with the low estimate outputs of 10 and a half years with an emission savings of 3.7 metric tons per year, which is about 9,000 vehicle miles avoided. Let me run you through the next scenario as well, if you could advance one slide. This one has a few more details. Okay, and then I'll switch over to Matt. This one I ran for Middletown, Connecticut, and this one was with a ground source heat pump. And you can see here that I indicated both fuel oil and electric usage. I indicated my fuel oil by gallons and my electric by dollars, and then a percentage assigned to each. And then you can see here that, sorry, I'm getting quite a bit of feedback. Not sure. Okay, oh, no, it's still there. There might be someone who's recently unmuted. So if you've recently unmuted, you might want to mute back up. I don't know if others can hear that feedback. But then I'll just have to move this. The outputs, the payback, simple payback is 17 years, just over 17 years, with first year savings of about $1,700. And then most impressively, at least for me, is that your annual emissions reduction here is 66%, or 5.6 metric tons per year, which is nearly 14,000 vehicle miles avoided. So here, even though that initial payback, it seems quite high, the emissions reductions are quite significant. And again, what we're not accounting for is the cost of you replacing your current system, what it would cost us to go out, for example, buy another fuel oil boiler, and it's not capturing any cooling savings. I'm going to turn it over now to Matt Miller, and he's going to walk you through a variety of scenarios that he's run for New York.
Thank you, Val. Val, I just want to make sure that you can hear me. Looks like it is. And once
yes.
I get my slides up, we have your screen, but no slides.
Amy, I'm just seeing Matt's name and no slides.
I'm seeing Val's name and no slides. But I can talk ad lib. Again, I am Matt Miller with NYSERDA. I run our information products program, which is a wonky name, but essentially we are trying to engage the digital economy in the clean energy marketplace. So if you think of CarGurus, Zillow, we want to bring those same kind of resources to clean energy. And we're developing all sorts of tools. Very specifically, there we go. Okay, so there are, just very quickly, we've been focusing on both the supply chain as well as end-use customers. On the left-hand side, you see a customer targeting tool. You can see the little green area where the homes are south of Binghamton. That is a particularly key area for an application we are serving. We go back up a slide, please. And then what you see on the right is something that was developed before my time. It's called a lighting pattern book for homes. It had to do with lighting, LED replacements and that sort of thing. But within that are calculators and other information. And so our hope is that we want to incorporate this tool into a software development for what we're calling our home or comfort home program that incorporates both home energy audit work, as well as heat pump replacement work, and the combination of the two. Okay, next slide, please.
Matt, I'm just going to interrupt you for a second. I think that I'm hearing quite a bit of feedback, and I'm wondering if your computer speakers are on. If something else is on in addition to your microphone. Now I can't hear you at all.
And now the problem is I can't hear you.
I can't hear you.
Can you hear me now?
I can. It sounds the same.
Okay. All right. I sound that's coming through someone else's computer. Val, you're not.
I will mute now.
Yeah. All right. I've got my speakers off, so I'm going to talk. If there's any issues, just let me know. Okay. So, somebody give me a thumbs up. What you see on this slide is all the parameters that I looked at. And so I looked at 3 zip codes in New York: Troy, New York, which is close to where I am now, Garden City on Long Island, Lowville, New York, which is in the western side of the Adirondacks. And I also threw in towns near and dear to me of Lenox, Massachusetts, and Madison, Connecticut, so I can incorporate them in the review. I have only looked at ground source heat pumps and ducted and ductless air source heat pumps because those are areas where I have some familiarity and are pertinent to our particular programs. I focused on what I grew up with was boiler system, fuel oil baseboard hot water boiler system. I threw in a wide range of annual heating costs because I wanted to see what impact that had. I threw in a heating stove, or perhaps more a fireplace insert based on using propane, and again a range of annual costs. Included domestic hot water, and again running on fuel oil with some room air conditioning. Different size of homes I've looked at. I kept the age of the homes constant. Number of people 4 constant, the behavior is average. I can't see all my slides. I don't know who's presenting at this point, Amy, but I can't see everything. Anyway, I'll switch to the right-hand side, which is the outputs. Are very similar to what Val had presented. Hopefully, I'm going to slim this down in just a second in terms of a low estimate and a high estimate that Damon I hope explained why there was the range here. You'll see quite a range between the low and the high as we get into it, and various information others have discussed. So here, you can go to the next slide. Thank you. And again, I still can't see the bottom of the slide, but in any event, this slide shows you the comparison for installing a ground source heat pump system in the various zip codes that I mentioned. I've held constant the square footage of the home as well as the fuel consumption. And all the other factors that we've talked about, I held those constant as well. And so what you see are the low estimate and the high estimate where I wanted to focus in particular. And I think, nope. Got it? Okay. So, yeah, I am expecting that the audience is jumping to 11530 and seeing pound value exclamation point, saying, well, there you go. Please don't get hung up on that. I don't know why Long Island isn't working, but for some reason, that's one of the bugs that we're working on. This is a prototype, and these are the kind of things that occur, and I'm sure Damon is scribbling notes as we speak. The more important thing is that you will see a range of data for the other zip codes that I think are relevant and certainly speak to the value of the tool. As we've discussed, payback is quite high in terms of years, and higher in Connecticut, in the New England states, which I find a little surprising. But whatever the case may be, you will see there's about a $700 savings in the first year. Depending upon the location, that has an impact on the percentage of the operating savings. Pretty handy reduction in emissions, which I think is really substantive as we go forward. Clearly, you see the incentives vary from state to state, and of course, the installed costs are not small by any means, but certainly relevant to what we're trying to accomplish. You will notice here that the high estimates are almost double, if not more than double, versus the low estimates. And I think that will give people a lot of pause, but I think it is important to show that there are ranges. One of the questions, I've read the questions while the others were presenting, and I do see there was a question about, well, how realistic is this? I can tell you that the data I have seen, especially for the New York City area, which may be unique, but nonetheless, installation costs can vary dramatically. And so it is important to capture the range that we will see. Next slide, please. There's a zillion different scenarios that I can present to you, but there were a couple that I thought, well, at least for purposes of a large audience and just giving you some familiarity, that I wanted to focus on. So again, focusing in Troy, New York, I focused on 3 different heating systems: ground source, ductless air source, and ducted air source in a 2,500 square foot home. Not small by any stretch, I understand that, but thought it was prudent for this kind of application. Again, I held the fuel consumption constant, and you will see that the payback is on the high end 24.5 years for a ground source system, and in the 13-14 year range for both the ducted and the ductless air source heat pump. It was interesting to me, you know, as a casual user, I'm trying to be the person who doesn't get under the hood like Damon does, but who just jumps in the car and wants to see how fast it goes, that the ducted system actually had a better payback than the ductless system. And I assume that means that, well, the house is already ducted, or that the cost of the ducting is not incorporated into the design, so or into the calculation. So one of the things we have to look at. Again, operating savings are good. Annual emission reductions are terrific. Similarly, as we had seen before, you can see the range of incentives with the intent to make the ground source heat pump a whole lot more attractive for everybody. And again, the high estimates, which I can't see all of them, but that's okay. You get the general idea, and I hope you can see them. You know, once again, what we're showing are net costs for the air source heat pump systems, roughly in the $10,000 range. Based upon my own experience within the last 10 years, and again, as Val, I believe, mentioned, this does not include the cost for a one-for-one replacement. But if it did, if we were at end of life for the product, then I think we've got a really compelling argument here to go with electrification. So I think that's a pretty substantial you know, information that's provided by the calculator. So let's go on and look at the next. There's 2 more slides that I want to show. This is if we change the size of the house from 1,250 square feet to 2,500 to 5,000 square feet just for ductless air source, and kept the fuel usage the same. And you will see that in the smaller home actually has a very attractive payback. And I would say that's a small home with a very high fuel consumption. They probably leave the windows open, the front door too. Whereas if we went with a 5,000 square foot home, a lot more space than I would ever know what to do with, the payback is quite high, and gets even more atrocious if you look at the high estimate. So, you know, pretty simple. We can dwell on this if you want, but what I want to do is jump to the next slide, where I keep the house size constant, but I switch the fuel consumption. These were some of the fields that Val showed early on, that there are calculations, and Damon referred to, there are automatic calculations included, but I forced them to see what the impact would be. And so, you know, basically I tripled it, and then I quintupled the amount of fuel that was used, and you'll see the payback swap. So all of a sudden, and I don't know that this is a surprising result to any of us in the audience that, well, if you're using a lot more fuel, you're going to have a much better payback. But I think it's important, again, one of the things we're trying to make this a suitable tool for use in the marketplace, in the broader marketplace, by people who are assessing their options. Who probably say, look, I've always used fuel oil, or I've always used propane or whatever, and you know, what's this new whiz-bang stuff? But if at least what we call the leading edge of the primary marketplace, we'll start to see these numbers and make a very compelling case that that this is a prudent path to pursue. So I think that's there's some important findings here. I don't know if there's other things in this slide that I want to refer to, but again, a 4.3-year payback, even an almost 8-year payback for $9,000 worth of fuel use. And I'm sure there are people, that's not my fuel bill, but I'm sure there's plenty of people that do have fuel usage in that range. It's quite an attractive approach to the marketplace. And one more slide, which is just a summary. And this actually, I've been watching the questions add up as my colleagues were speaking. And, you know, there was a goal here, as Val talked about, in terms of making it simple to use and making it accurate. So, you know, in my getting behind the wheel, taking it out for a test drive, that's what I wanted to see. Is it simple to use and is it accurate? And I think where we are in the evolution of this product, it's moving towards meeting those goals. I do not want to mislead you and suggest that everything is rosy and it's ready to roll. And I share that because everybody's involvement here is really important. There is a continuous improvement aspect to any of these programs. Programs are notorious for having bugs. This is the kind of stuff that keeps Damon up late at night and on weekends. And all of those are being addressed, but the feedback that everyone can provide as we go forward, the kind of quantitative analyses and user feedback are going to be very, very, very valuable, because I think there's really something here that is, it is relatively simple to use. Certainly when it's on a web page format, it'll be even easier to use. And I think the accuracy is getting pretty darn close. We at NYSERDA have worked with a lot of different tools, and you know, there's slowly a consolidation of thinking and approach that is working well. I do want to address one of the questions that was raised early on, and again, I know there's a whole bunch of questions being asked, so I'll step to the side of the speaker in a moment. But the question had to do with why did we focus on end users and not contractors, making the tool suitable for both. Everything that I do in my work prior to NYSERDA as well as now is, and the term that often gets used is democratization. But if you think about Zillow, if you think about Car Gurus, if you think about LendingTree and other sites like that, the intent really is that it levels the playing field to allow a potential customer to be able to speak the language of those that they're going to be working with, who they really don't work with a lot. So as I see this tool, it allows someone to do an initial evaluation and then have a reasonable conversation with someone who is knowledgeable and allow them to build the trust. So it really is about building bridges between the end users and the suppliers. And that's just critically important to what we're trying to do here. And it's really a two-way street, because the suppliers really only want to focus on opportunities that are valid. And you know, most are small businesses, and they want to be able to have as much success as possible. So I will leave it there. Again, there's about a zillion other different permutations of the model that we could run, but I wanted to give you at least some sense of different things that I looked at, that I had a certain familiarity with, and the appropriateness of the results that I received.
Thank you, Matt. And that was a perfect
to you, Val.
segue. Yeah, thank you. That was a perfect segue to talking about next steps. But before I do that, sorry, Damon, I wanted to put you in the hot spot and see if you wanted to give any feedback or share any insights on some of those results that you saw. We could
Sure.
throw
Yeah, there's two that I feel like I could answer quickly, and I've been trying to keep up with the questions in the chat as well. But two that Matt raised. One was he's having an issue with zip codes on Long Island, and what that is it's trying to look up data and assign that home into a bin in the REX data. REX was done in 2015, where we had a particularly warm year, and it can't find a zone in the REX data that has that mild of conditions, but we have since fixed that. Not with an ideal fix, but we have some kind of heating degree day shifting going around that is trying to do the best with the data that we have. Matt also mentioned the high and low outputs and the comments. There's been some comments on that range, and I had neglected to mention that when I was going through the first time, because as I was saying, we don't have a real sense of the capacity of the that's required for a given house without being in the house and really doing some measurements. I feel like that's one of the less precise parts of the tool. And then on top of that, the pricing does vary quite a bit. So we do put a range in on that section, and you end up seeing it come out in the capital cost is where there's this big range. And we wanted a range in the tool anyway, because there is a real range in real life, but we use the uncertainty in the system sizing and costing as a way to introduce that range.
Great, thanks. Was there anything else?
No, those were the two I had noted, and I'm trying to scroll through to see if there's anything else. People can check the chat. There's a dozen or so questions in there.
Okay, well, feel free to hop in at any time. I know there are lots of questions, so let me quickly move through the next step. So the next steps for this tool is continuing to revise the Excel spreadsheet, and once that's been done and we feel confident in the outputs, it's going to go to a web designer. We're working with Vermont Design Works up in Burlington, and they're going to make the online user interface, and we're super excited to see that. Matt raised the point, one of the questions someone had asked about, why did we focus on homeowners? Well, we do have funding for phase 2 of this tool, and this is actually something we've been discussing as a group since day one, because we would like to see a more robust tool that either a savvy homeowner could use, but ideally this would be a tool that would benefit contractors and installers and people going directly into a home. So someone who has run an energy audit or has other data about the home could go ahead and populate fields. So this would be a more robust tool that could give a more accurate result, just given the more specific data that's been entered. So that's phase 2 under discussion. It won't get underway until we finish phase 1, of course. And then the other thing that's underway is we're going to be expanding this tool to other states in the Northeast, which is very exciting. All right, sorry, taking up a lot of your time, and I know there are lots of questions, so we'll turn it over to Nikki for those.
Sorry, just taking myself off mute. We have tons of questions, which I think is really a testament and a compliment to the relevancy of your work and of the broad interest in exploring some of these other options. You know, we've got less than 10 minutes left, and I really can't choose which questions are more relevant than others. Val, if you and Damon and Matt maybe want to each pick one question, either from the Q&A section or from the chat section, and then we can talk maybe a little bit after about putting together maybe a Q&A follow-up document that we can post and distribute on our Basecamp site, because I would love both for our members to be able to have some answers to the questions that they have posed, but I'm also hoping that your team would really find some benefit in maybe looking through the questions posed by our participants today. So why don't we try just kind of one question each for now, and then to all our members, we will try to put together something where we are addressing your questions offline and distributing those answers to everybody.
Yeah, and I will say, sorry to jump in again, I haven't had a chance to look through the Chatter Q&A, but there will certainly be more webinars, especially once the tool is finalized and online. We'll host one of those to unveil the tool, but also before the tool goes online, we will be looking for feedback. So we're really going to be looking to contractors and installers to take the tool out for a test run and give us your feedback. So if you're interested in testing the tool before it goes live, please get in touch with me.
Val, one of the questions I had was that I had shown a 2,500 square foot house requiring $2,500 of fuel oil, which works out to about $3 a gallon, I guess, which seems to be low for what the field is seeing. You know, and it may be. I pushed a lot of numbers around. Was I trying to be realistic? I was trying to be reasonably realistic, but I was also trying to convey you know, message in terms of how well the tool works in terms of comparisons. So forgive me for any errors that I have made. One of the other questions that came up was, can you input your own data? And that, as much as anything, was what I was trying to show, is that yes, you can. And that's one of the beauties here, is that Damon and team have incorporated a lot of standards, but they've also allowed flexibility for you know, individual circumstances. And you know, we're all very different website users, and having that kind of flexibility, I think, is really magic and a real credit to the work that's been accomplished so far. So hopefully it won't be too long till others can use the tool and put in their own data and what kind of results they get. I'm going to take up too much time here, but you know, as people use the tool, hopefully we'll be able to receive feedback on the kind of input they're getting, and that too will be a stream of data to give some sense of what is the real world seeing and seeking.
Thanks. And I've quickly looked through some of the questions too, and one that stood out to me. So in phase 2, one thing that we've been talking about is how we can integrate the phase 2 tool with current modeling, other modeling tools, like someone mentioned Energy Plus. So that is an idea we've talked about for phase 2, is how to integrate other tools, like energy auditing tools, into phase 2.
Also mentioned there was a question as to whether the tool will provide feedback to the policy makers to identify gaps in the incentives where payback is unfavorable. I can only speak a little bit to what's done at NYSERDA, and I assure you the answer is yes. I can tell you the folks that do that work are in a league above me in terms of their skill sets, but they most assuredly do look at this kind of information all of the time. But as much as I focus on, you know, the end users, the people out in the marketplace who are still trying to get comfortable with this technology. You know, solar and EVs have sort of crossed the threshold. We have a way to go on heat pumps, and I think it's really important. Electrification.
Damon, I wonder if you could answer some of these questions, or are asking why the tool doesn't, why I don't know, why it doesn't take into account heating distribution systems or cooling. It seems like folks are saying, it seems like for a robust tool, there's a lot that we've left out. You could quickly address that, sort of the balance that we were seeking.
Yep, we didn't want to ask too many questions that seemed too hard, or ones that the users would be likely to get wrong. We thought distribution is one that we do ask questions about. Do you have a hydronic system with example baseboard radiators, and trying to reach them with language they can use. But one of the things we do calculate the cooling energy. I think what Val was saying earlier is we don't, if you're adding a heat pump that's giving you new cooling, we will show the impact of that cooling energy, but we don't then compare that against, well, you would have bought an air conditioner had you not gotten this heat pump, because we don't think that's necessarily true. But that would be a more robust comparison if that's your situation. Someone did ask, this really doesn't support electrification, and I think it doesn't against natural gas, which is something I think shouldn't be too surprising, but there are definitely scenarios in here that do work, and against propane or fuel oil, well, at least with the prices that we've had, we'll see in the future, it was showing electrification being cost effective and good emissions reductions.
Hey, Val, as we wrap up the hour, let me just say this. I'll go out on a limb here and say, if somebody wants to send me the kind of inputs that they would like to see, I'd be happy to run some trials for them, see what kind of results we get. And I will end on this note. We are going to get through this current moment in time. And the goal that I see in the range is putting people back to work. And if we can help the industry, pump installers, the HVAC installers, and we will have done a good job. Thank you.
Thanks, everybody. I think we will wrap this up unless there's any last comments from any of our presenters.
This is Val. I'd just say that on the last slide, you'll find my contact info. So likewise, feel free to reach out with any follow-up questions.
And we will get this webinar recorded and posted on the Renewable Thermal Alliance Basecamp site. So if we have anybody participating today that's not on our Basecamp site, I'm going to put my email in the chat. Email me if you'd like to get signed up to receive this and other subsequent announcements within our group.
Thanks so much for hosting us, Nikki.
Thank you, all three of you. This has been fantastic. I'm really excited about how far this project has come.
Great.
Thank you.
Thanks, everyone. Take care.
Bye, take care.
Bye.